In this video, we will review tomographic equipment. Although tomograms have been mostly replaced with computed tomography, some tomographic images are still performed in the radiography department today. Tomography is defined as the use of movement of the X-ray tube, the patient, and/or the image receptor in order to blur out anatomical structures which may superimpose the specific anatomy of interest. Typically, when we are referring to tomography, we are referring to when the tube and the image receptor are moving, and the patient or body part are still. Here we see the X-ray tube, patient, anatomy of interest, and the image receptor. Watch as the image receptor and the tube move in opposite directions of one another, and the anatomy of interest stays centered within the central ray, as well as on the image receptor during the continuous and extended exposure. What you just saw was the simple premise behind radiographic imaging. The anatomy of interest will be visualized on the resulting image, while the anatomy above and below the area of interest were blurred. Terminology associated with tomography varies, but there are some main terms that you need to know. The first term is the fulcrum, also known as the fulcrum point, and this is the focus or pivot point where the X-ray tube and the image receptor meet during the tomographic exposure. The focal plane is the area at the same level of the fulcrum that is recorded on the image. This is sometimes referred to as the level, slice, or cut. You should be familiar with all of those terms describing the level of the fulcrum. Amplitude is the linear distance traversed by the X-ray tube during the tomographic movement. In linear tomography, this is the same as the exposure arc. The focal depth refers to the location of the focal plane in relationship to the X-ray table. Oftentimes, the focal depth is varied to view the anatomy entirely. Additional slices are performed at intervals to cover the area of interest. The focal depth is determined by measuring the distance from the table to the area of interest. Slice interval and slice thickness are two terms a technologist should understand. The slice interval is the distance between each slice. If this is set too narrow, the slices will overlap, and this will increase patient dose unnecessarily. If the slice interval is set too wide, there will be information missing because the slices will not cover the volume of anatomy. Slice thickness, on the other hand, is the thickness of the actual slices. This is determined by the set exposure arc. As the arc degree increases, so does the slice thickness. Thinner slices mean better detail and less chance for artifact, but also means the technologist will need to perform additional slices to cover the area. As always, it is all about balancing risk versus benefit. Oftentimes, the radiologist is the one who determines the protocol for the tomographic images and gives guidance based on the scout tomo projections. The level of the focal depth is marked on each image. For example, a 6 cm slice would have 6 cm on the image. Lead number markers are ideal to label the focal depth on each tomographic image. Lastly, you need to know that exposure factors for tomographic images need to be manipulated. MA setting will need to be low to allow for a longer exposure time of 3 to 5 seconds. On average, tomographic exposures require twice the overall exposure or 2 times the MAS of the same radiographic exposure performed without tomography. I hope you found this video helpful in understanding tomographic equipment and its usage.